Hello everyone, so I'm going to work through question 5.3.2 of the paper 2 exam that was written on Monday. Now this question was highly requested and I have just copied and pasted basically what the question was asking for. And it's also important that we know what was asked in 5.3.1. So in 5.3.1, they asked you to derive that identity. Now, whether you could or not, you could still attempt 5.3.2. I want to point out to you guys that they're saying hence or otherwise determine the general solution of this equation, which I've just rewritten. Now, guys, when they are saying hence or otherwise, that means that you can use this identity written up here, but you also don't have to. Now, hopefully you guys can recognize that this expression that we have on the left is a trig compound angle identity that has been expanded. It's actually the sine compound angle identity. So we can replace this with sine of 48 degrees minus x, right? On the formula sheet, you have an identity that says sine of A minus B is equal to sine A times cos B minus cos A times sine B. And that is exactly what we have here on the left. We have sine of an angle 48 times cos of an angle x minus cos of an angle 48 times sine of an angle x. So what you could do is you could replace what is on the left with sine of 48 degrees minus x, and that is then equal to cos 2x. That now would leave us with a problem here because now we have a sine on the one side and the cos on the other side. We need sine equals sine or cos equals cos. But this is a problem that is very easily fixable. We can change cos 2x to sine of 90 minus 2x, and we can solve the equation from there. But guys, something else that you could have done, if you wanted to keep it cos on the left equal to cos on the right, you could change this original expression that we have up here, sine 48 cos x. You could change this to cos 42 times cos x. What am I doing here? I'm using co-ratios, right? Because 42 is the same as 90 minus 48. So sine 48 and cos 42 are equal to each other. And you could then do the same with the cos 48. You could change it to a sine 42 times sine x, because now what we have on the left here is actually a cos double angle identity, right? Similar to the one that we had to prove in 5.3.1, the only difference is that this one has a plus in between the terms, which then is a minus in the identity. This one now has a minus in between the terms, which is going to change to a plus in the actual identity, in the bracket, the compound angle that we have. So that is going to leave us with cos of 42 degrees plus x equal to cos of 2x. This equation is slightly easier to solve because we don't have a bracket equal to a bracket like we had in the sine equation up there. But either way, you would get to the same answer. So I'm just going to continue working from here with my cos equals cos. This now means that my reference angle is 2x, and I need to write equations in my quadrant 1 and 4 because that is where cos is positive, and this is a positive expression, right? There's no sign there, so that means that there is a plus. So now I'm going to write a quadrant 1 solution. I'm going to say the angle on the left, which is 42 plus x, is equal to, what do we do in the first quadrant? We just use the reference angle as it is, and then we're going to say k times 360, because the period of a cos graph is 360 degrees, k element of z. You can use n, you can use any letter that you want there in the place of k. And now we need to solve for x. So I'm going to bring this 2x over. I'm going to say x minus 2x is negative x. And on the other side, I'm going to have a negative 42 plus k times 360. And now I need to divide by negative 1. So x is going to be 42 degrees minus k times 360. Now guys, you actually can leave that as a plus. The sign of the k 360 doesn't matter. It can be positive or it can be negative, because remember, k is actually a variable. It's a placeholder, which is going to be an integer, and an integer can be positive or negative. So you can leave that as a plus or minus. It doesn't actually matter. For our quadrant 4 solution, you have two options. You can either do 360 minus the reference angle, or the faster way of doing this is if you have your angle again on the left equal to negative reference angle, because in the fourth quadrant we have negative acute angles, right? So that is probably the quickest way, but it's also fine, guys, if you did 360 minus 2x. You'll get an expression that will yield the same answers in the end. So it's fine if you did it like that. So now we're going to move this 2x to the other side. We're going to have 3x equal to negative 42 plus k times 360. And now you need to divide by 3. So let me just quickly see, what is 42 divided by 3? That's 14. So we have negative 14 plus k times 120 degrees, and those are the two general solutions for